Hi everyone, here's a narration of my slideshow about gravity. I will also narrate the gravity worksheet after this. So just to remind you, you can either work through the slideshow and then complete the worksheets that is in this assignment as well, or you can work through part of this slideshow, pause when there's a question, and then move on to the worksheet and come back and sort of do it that way. Either way will work just as well as the other. So learning objectives for this: 1 is to define mass and weight, 2 is to understand the force equation F equals ma, and 3 is to apply the force equation to gravity. So forces. We have learned how forces work and what they do. Now we are going to apply some maths to physics. Here's a video of Veritasium kind of doing a little overview of some ideas we'll be talking about in the slideshow. I recommend going to the PowerPoint and watching this now and then coming back here. From the video, there is a little comment that I saw that I thought would be interesting. So here's an extra for experts. It is not necessary to do this or think about this, but it might be useful. So this is a comment from a person 6 years ago. I remember the example I was given for this years ago. The idea is that an astronaut on the moon lifts up a big rock, and because it weighs less than on Earth, he finds he can lift it with little trouble. So he decides to see how far he can kick it and breaks his toe because the inertia is the same as it would be on Earth. So here's a comment on the video you just watched. The question for experts: why is the inertia of the rock on the moon the same as that on Earth? I'll give you a second to think about it. You can always pause this video and think about it in your own time as well. So moving on to the force equation, we use a very simple equation to calculate force. It is F equals ma. So in this, F equals force, m equals mass, and a equals acceleration. The next few slides will go over mass and acceleration, just because we've gone over force quite a bit already. Mass. Mass is the amount of matter in an object. It is related to the density of atoms in an object along with the amount of space it takes up. For example, mass is denser than fat. This makes weight useless on its own when trying to assess someone's fitness, as a fit person may weigh more than an unfit person. Mass can be measured in grams, pounds, kilograms, tons, etc. So here's a little question to think about. When you stand on a weight scale, what do you see? What is the number that you see here? Give you a couple seconds. You can always pause this, and I'm going to move on now. When you stand on a weight scale, what do you see? The answer is that you see kilograms. That's the number that you would see here. Therefore, a weight scale isn't actually measuring your weight at all, it's measuring your mass. Weight scales use the force your body pushes downwards, your weight, to measure your mass. And so that name is a little bit misleading. Acceleration. Acceleration is the rate at which speed changes. So which chart out of these two shows the more acceleration? Is it this chart where in 6 seconds it travels up to about 6 speed, 6? Or in chart B where it travels up to about 12, let's say meters per second, in 6 seconds? So speed of 12 in a time of 6, or a speed of 6 in a time of 6. This is just something to think about. So the answer is that chart B has more acceleration because in the same amount of time it reached a faster speed. So as you can see, it reached a speed of 12 in 6 seconds, which is twice as fast as this one where it only reached a speed of 6. And so here's a little example for you to think about. Both of these graphs chart the motion of this scooter. Because it is the same scooter, Both charts have the same mass, so mass is exactly the same here. Part A of this question, in which should be answered in the document in here as well. Which chart is traveling faster / accelerating faster? So out of these two, which one has a faster acceleration? Part B, which chart shows a stronger force? Hint, if acceleration increases, will force also increase? You can try this out by testing out with some fake numbers if you want to have a little play around with the formula, but otherwise this question is just asking which has a stronger force. And so moving on from that, so force is a relationship between mass and acceleration. What does this have to do with gravity? Gravity is a type of force, so it also follows this equation of F equals ma. However, this acceleration is the same wherever you go on Earth. Gravity equation. Gravity uses a modified force equation, where F equals ma for gravity. This is F equals mg. M equals mass, and g equals acceleration due to gravity. The equations are basically the same, but adapted for gravity. Acceleration due to gravity. This is a constant no matter where you go on Earth. On Earth, this is 10 meters per second, or 10 meters per second squared, so g is equal to 10. Therefore, on Earth, if you use the formula, F equals m times 10. So here is the second question to answer. It is called 2 gravity example, and the question here is, what is the force that gravity pulls down a 70 kg person by? Part A, what is the mass for this calculation? Part B, what is the g here? What is g in this calculation? And part C, finally, what is the force due to gravity? Use F equals mg. So you can answer this question on the worksheet now, or you can follow on with me. So what is gravity? Gravity is a force that pulls an object towards any other object that has mass. Therefore, humans have gravity, though our gravity is too tiny to have any effect on others. The bigger the object, the bigger the acceleration due to gravity, g. Weight is equal to force because of gravity. When we feel our weight, what we are feeling is the relationship between acceleration due to gravity and our mass. This is why in force diagrams, either weight or gravity can be used on the same force arrow because they are the same thing. So thinking back to an example of an apple falling, for the arrow pointing downwards, you could either use gravity or weight for the name because they are the same thing. Here is the final question, question 3. How strong is gravity on other planets? Use this website to find out how much you would weigh on other planets. You don't have to use your own weight if you don't want to. Any mass is fine in kilograms. So here's the website. On the document, fill in your weight on any other 2 planets or celestial bodies. And so here is the condensed notes that you need to remember from this slideshow. This is separated out according to the learning objectives, if that helps you make notes. But mass is the amount of matter in an object. This is related to density and the amount of space that the object takes up. Weight is how heavy this object is due to gravity. Force is calculated by the equation F equals ma, F equals force, m equals mass, and a equals acceleration. For gravity, this equation is F equals mg, where g is the acceleration due to gravity. On Earth, this acceleration is always 10 meters per second squared, or you can just write it as 10. Quite often you can just write it as 10. But that is the entire slideshow. Well done if you've been working on the worksheet alongside this, because you're now done. If you haven't been, you have the worksheet to do and then you will be done. So hope you all have fun and see you tomorrow. Here is a little narration of everything that's on the worksheet as well, if you want that. So question 1 on the worksheet, example of F equals MA, which is on slide 11. Which chart is travelling faster / accelerating faster? In part B, which chart shows a stronger force? Hint, if acceleration increases, will force also increase? You may try this by testing the equation with some fake numbers. So once you've answered that, question 2, gravity example from slide 16. What is the force that gravity pulls down on a 70 kg person on Earth? So part A of this, what is the mass for this calculation? Part B, how much is the g here? So how much is that g force, the acceleration due to gravity? And C, finally, what is the force due to gravity? Use F equals mg. And the final question here, question 3, how strong is gravity on other planets? This is from slide 19. Use this website to find out how much you would weigh on other planets. You don't have to use your own weight if you don't want to. Any mass is fine in kilograms. So part A is what is wrong with this website? And it's just asking here, well, part of this is mass weight? If you read through this website, it will hopefully be clear of what is wrong with this website. And part B, fill in this table with 2 other planets or bodies in space from this website and how much your weight would be if you were on these other bodies in space. So here I have the name of the planet or space body, so Earth first off, and the weight that your mass is on these other planets. And then you're done.